Hello everyone, welcome to UrbanSubnet.com. Today we're going to do an exercise here with some IP address assignments and some routing between these two computers. We have a PC Don over here and we have a PC Keisha over here. So what's going to happen is we're going to set up a connection from Don to router 1, from router 1 to router 2, from router 2 to router 3, and router 3 to Keisha. And what we're going to do on this particular network is we're going to have several different networks. So we're going to have a 10.10.10.0 network with a 24-bit subnet mask. We're going to have a 20.20.20.0 subnet with a 30-bit subnet mask. And we're going to have a 172.16.20.0 network with a 29-bit subnet mask, and then we're going to have a 172.30.30.0 network with a 24-bit subnet mask. In this video, I want to give you an example of the networks, the different numbers that the networks can have and how they will work together. How are we going to get Don to be able to reach Keisha, who's all the way in Brooklyn, New York, and Don is down in Charlotte, North Carolina. And this could be a real world situation. You could be working for a company that has offices in Charlotte and offices in Brooklyn, New York. So to get started, the first thing we're going to do is we're going to bring up our terminal emulator on the PCs, and we're going to use a console connection to connect to the routers. Now, when we assign IP addresses to the PCs, this is a virtual PC environment here, so it's not what you would do with your Windows computer if you were assigning and checking IP addresses on the Windows computer. So I just want to make that clear that this the software on these PCs is not what you would actually be using at home, but they give you an idea of how things should be done. Okay, so let's get started. So we've opened up a terminal emulator with the PC Don. So now let's open one up on the router, and then let's open one up here on this router, and then one for this router, and then the last one is going to be for the PC Keisha. So we have our terminal emulators down here. So the first thing we're going to do, now the IP address scheme is going to go across like this. 10.10.10.0 is going to be here. 20.20.20.0 is going to be here. 172.16.20 is going to be here. And 172.30.30 is going to be the last network leg over here. So on PC Don, the first thing we're going to do is we're going to do show IP. And we see there's no IP addresses whatsoever. So we can't ping anyone or reach anyone at this point. So we're going to put IP 10.10.10.2 /24. The gateway is going to be 10.10.10.1. And we're going to press enter. Now it's going to check for duplicate addresses first, and then it's going to find that there are no duplicate addresses, and it's going to assign PC1, which is this PC here, 10.10.10.2 IP address, subnet mask 255.255.255.0, and a default gateway of 10.10.10.1. So we have configured this PC with the IP address that we like it to have. So next we're going to go to router 1. We're going to go in here, and then we're going to go into the interface FA0/0, and we're going to put IP address 10.10.10.2 255.255.255.0. Now you can see the commands are different between the different devices. So routers run a operating system called iOS, and this is how you enter in the IP address for the iOS devices that are running iOS software on it. So we're going to entering that address, press enter, and we do a no. Now before we do no shutdown, we're going to run a test here. So we're just going to ping 10.10.10.1, and it is not going to work for us. So it says the host is not reachable. And the reason why it says the host is not reachable because there's not even a connection between the two of them. So let's do this right here. Let's go to router 1 and do the no shutdown. And now we go back to the PC. And we try to ping again. And let's see what happens. It says the host is still not reachable. So let's go back here. It says line protocol interface, 0 change state to up. So it's saying we have a duplicate address here. So let's see. And we certainly do. So that's why it doesn't work. So see, this is a lesson for all of us. We have to be very careful when we put in our IP addresses, so we will put in the correct address. So what we're going to do here, we're still in interface FA00. We're just going to do no IP address. And we're going to remove that address, and then we're going to just up arrow here, and we're going to change this 2 to a 1. And see, a lot of your devices will give you warnings to let you know exactly what's going on, so what went wrong here. So now we're going to put that in, and then we're going to go back to PC1, and then we're going to try to ping again. So now our ping is working. And some of you might have noticed when I was typing and seeing that I was making a mistake here, but we were able to identify that and correct that. This can happen in the real world in any day, where somebody might call you up and say, our PC can't reach this particular router, we can't get on this network, and you may have to go in there and do some troubleshooting and may notice that there's a IP address conflict of some kind. Maybe it could be the wrong address, could be the wrong subnet, or something like that, maybe even the wrong interface. So you have to check everything to make sure it's all correct. So now that we have that done, we have the connection between the two of those. We're going to come out of here and we're going to ping the other end, 10.10.10.2, and everything looks good. So now we have another connection that we're going to form from R1 to R2. So this interface here, FA01, we're going to go into that. FA0/1, and we're going to put IP address 20.20.20.1, and we're going to put a subnet mask at 255.252, because we're using 30 bits of the subnet mask. Now 24 bits would be 255.255.255, because all of these bits are ones. So in an octet, when the 8 bits are all ones, it equals 255. But in this one, we're not using all of the bits. We're using the first 6 bits, because there's a 32-bit subnet mask. Remember, subnet masks are 32 bits long. So we're using a /30, which leaves 2 of the bits still unused, but it comes up to the number 252. So this will be our subnet mask, 255.255.255.252. So what we're going to do here now is we're going to press enter, and then we will do no shutdown on this interface, and we should come up momentarily. And there it is. So the interface has come up, and it has an IP address assigned to it. So now what we're going to do is we're going to go over to this other router here, router number 2, and we have to connect him up to router number 1. So we're going to do the same thing, config T. We're going to interface FA0/1. FA means fast Ethernet, everybody. Fast Ethernet is 100 megabytes per second. So you got 100 megabytes per second fast Ethernet, and you got gigabit Ethernet, which is 1,000 megabytes per second. So here we are on the fast Ethernet 01. We're going to do IP address 20.20.20. 2, and we're going to do 255, 255, 255, 252 for the subnet mask. And we will press enter and enter that in, and then we will do the no shut. And you can abbreviate this command to just no shut and it will still work. So you don't have to type in the whole thing, no shutdown. Sometimes you may be in a hurry, want to get things done or get a network back up, so you can abbreviate some things. Now we see the interface has come up. So the first thing we should do to test our connection is we're going to ping router number 1, which is 20.20.20.1. And let's see what happens. Now, the ping went through. The first ping was used to establish a routing table or ARP table between these two. ARP stands for Address Resolution Protocol. So if we do show IP ARP, Address Resolution Protocol is running here. So these devices, when they communicate on the LAN, they use this hardware address to communicate with each other, and what they'll do is this guy will find the MAC address of this router 1, and then he will say R2 will find them, will send an ARP request to R1 to find out the MAC address and what interface R1 is off of. So that's what he's done here. So his first packet established this ARP table. The remaining 4 packets were sent across, and they knew who each other were and how to reach one another. So he replied back with a to the packet. So the ping was good, and we see our success rate was 80%. 4 packets were sent back, or 4 packets were received back from router 1. A total of 5 was sent, but 4 was returned back. Okay. So now that we have that there, let's see from R2 can we ping PC1 or Don's PC, which is 10.10.10.2. Can we reach that person? And we're not able to reach them, and the simple reason is that they are on a different network than we are. This computer right here is on let's do this here. Alright. Fast Ethernet 01 is on 20.20.20 network. It is up and is up. But over here, Don's PC is on a different network. His PC is on the 10.10.10 network. So they cannot reach each other yet. Now that particular issue has been solved, and I will go into that a little bit later. But first we're going to go ahead and continue on with our connecting these devices together. So now in R2 we have a connection to R3. So what we're going to do on R2 is we're going to go into FA0/0. We're going to do interface FA0/0. And then we're going to put IP address, and the address on that particular link is going to be 172.16.20.2. So we're going to give this one .2, and we're going to give them a subnet mask of 255.255.255.248, because now in this particular one we're using a 29-bit subnet mask. So you all can look at the subnet mask video and see how we total all of these up. But what we're doing here, we're just counting the bits that are on. The bits that are all ones are being counted. So these bits are on. The last 3 bits in the last octet are 0. So we come up with the number 248. I'm going to press enter, and then we're going to open up the interface here with the no shutdown command. Now these particular subnet masks, what they mean is we can have more hosts on these networks. So on the 24 network /24 network, we can have 252 devices connected to it. On the /30 network, we can only have 2 devices connected to this particular network. So this is normally called a point-to-point connection. So what we did is we made one address here and one address here. So that's a point-to-point connection with this particular network of 20.20.0.30. I mean 20.20.20.0/30 network. So now on R2 we've added a /29 network, which is going to give us 6 hosts. So we have 6 usable addresses on the /29 network. So we're going to go over here to R3 here, and we're going to go into that interface, FA0/0, 0/0, and we're going to put IP address, and it is 172.16.20. So now on this one we're going to do something a little different. We have up to 6 IP addresses that we can use on this network here. So the IP address that we're going to put on this network is 6. So we're going to use the number 6. We're going to do 172.16.20.6 with the subnet mask of 255.255.255.248. Okay, and then we're going to do a no shut, and we should see the interface come up momentarily. Now we're going to test our connection simply by sending a ping to 172.16.20.2. Well, 2 was the other one, so let's see what happens here. So that worked. So 172.16.20.2 is reachable from our router 3, which has a an address of 172.16.20.6, and this one over here has an IP address. Let me show you something that we use a lot in the networking field. We can copy this command. Well, we want to it's pasting it, but I wanted to copy it. So actually highlighting it copies the command. Then we go to router number 2, and we paste that command in, and we see the interfaces that are up. So we have 172.16.20.2 up over here, and 172.16.20.6 up over here. So now how this works here, we have 6 usable IP addresses on this network. So we have 0 through 8 is the numbers in this field. Now the number 0 we cannot use because that's the network number. So we can use 1 through 7 because we cannot use the number 8 because 8 is the broadcast address of this network. So each network has a network number and a broadcast address number. You cannot use those addresses to assign to your devices. So if you have a /30, actually I'm looking at the wrong, but if we have a /29 subnet which has 8, which is 8, the bit value of the 29 bit is 8. So that bit value is 8. So we have to subtract 2 from 8, which gives us a total of 6 usable addresses. So 172.16.20.0, we cannot use that number on a computer device. So we can use 1, 2, 3, 4, 5, 6, 7. Then when we get to 8, we cannot use 8 because 8 is what we call a broadcast address, which would send a packet or to all of the people on this network, or all the devices on this network. If we sent a broadcast packet out, it would be sent to every device on this network. 1, 2, 3, 4, 5, 6, 7 would receive that broadcast address. Okay, so that's how that works with these different subnet masks. So now our last network segment is going from router 3 over to PC Keisha. So what we're going to do on the R3, we're going to go into the FA01 interface, and we're going to put on an IP address of 172.30.30.3, because when we have a 24-bit subnet mask, we have 252 network hosts that we can assign. So we got numbers 1 through 254, 253 that we can use here on this particular network. So we got a lot more hosts. So we're going to use number 3 for this computer. We're going to do the subnet mask. Then we're going to do a no. And now we're going to go to PC Keisha. And we see the interface came up for us, which is good. And then we're going to do IP 172.30.30.2, and we do a /24, and the default gateway was 172.30.30.3. Right? Okay. Yep. 30.3. Just making sure. Then we're going to press checking for duplicate address, and it does not see one. So now we should be able to ping our our router 3 should be able to ping router 3 at 172.30.30.3. And there it is. Okay, so that's work. So what we have done right now is we have connected all of our devices together. So what we're going to do next is we're going to save our configurations on each of our routers. So to do that, the command I like to use is copy run. So that's copy the running config into the startup config, and it says destination file name is startup config. You see that there. So it's going to build the configuration. It's going to save it for us, and we're going to do the same thing here. Copy run start. Same thing there. And over here on router number 1, and there's another command that you can use for this too, which is called write memory. So you can do the write memory command too, and it builds the configuration too. But when we do the copy run start, it tells you more about what the router is doing. The router is actually saying, I'm going to have a destination file name called startup config, and then I'm going to put that in the startup config. If we do a show, okay, so let's do this here, directory. Alright, so there's no flash or whatever on this, but if you was on a real device, there's a flash memory module that you can use to see what is actually on the flash drive, what files are on there and how much size they take up, etc. So now let's get back to our original task, which is Don wants to communicate with Keisha, but at the moment, if we go to Don's PC here, we're on Keisha's PC, and Keisha's address is 172.30.30.2. If we go over to Don and we try to ping, okay, we can see our ping to Keisha did not work. So it says destination host is unreachable. So in order to fix that, we have to configure a routing protocol on our router so the routers can route to one another. So what we're going to do is we're going to go into R1 and we're going to do a simple routing configuration here. We're not going to do anything fancy. We're just going to do config T, and then we're going to do use the open shortest path first routing system, and we're going to do OSPF. We got to give it a number, so we'll give it a number of 100. So we're going to do that, and then we're going to put in here network. We're going to just put a default network of all zeros, then area. Oops. 0, area 0. Okay, so we put that in there on router number 1. So we're going to go to router 2 and do the same thing. Router OSPF 100, and then we're going to go over here and we're just going to copy this right here, and we're going to put that in on router number 2, and then on router 3 100, and then we're pasting the network. So now all of these routers are on different, well, these routers are connecting different networks, but what we did now is we instituted or configured a routing protocol that's just going to say this OSPF, Open Shortest Path First 100. That's just a process number that we have to give it. But we're telling OSPF to route traffic for every single network that there is. So that's why we put the all zeros here. So what that does is we do a show. It tells OSPF to route traffic for this interface and this interface here. So what we're seeing here, we just got a log message in that says OSPF 5 adjacency. So the process is number 100, and the adjacency change message here for process 100 says our neighbor router 172.16.20.2 went from loading to full. So loading is done. So it says that it has a complete routing table to the adjoining router, which is router number 2 here. So what we're going to do here is we do show IP OSPF neighbor. We'll see that we have a neighbor relationship with router number 2. So what we're going to do here is we're going to now go back to Don and see if he's able to ping Keisha, which is what we're trying to get accomplished here today. Now let's see if that works. Alright, so the first 2 timed out, but now we have received 84 bytes back from Keisha. Keisha's all the way on the 172.30.30.2 network, all the way up in Brooklyn, New York, and we're down in Charlotte, North Carolina. So what we have done in this particular video was we set up different networks with different IP addresses across a simulated area, a geographical area from Charlotte, North Carolina, all the way up to Brooklyn, New York. And this is a logical view of the network, or a topology type view of the network. But you're going to see this as you working network, and you get a topology view, but your routers can be in several different locations. You know, I've worked with companies that had routers all the way across the country. I would be working up here in the Virginia area where I work, and I would be logged into a router all the way out in Hawaii. And I would be configuring a router in Hawaii to communicate with a network back in Washington, D.C. So these are the things that you have to do. Now between, let's say this router right here, router 1 is in Charlotte, and say that router 3 is all the way in Brooklyn, New York. Okay, in between these two is a phone company network. So even though on our view we only see 3 routers, there may be 6 routers between Charlotte and New York that are sending the traffic. It may be 20. But the point is, these routers know how to reach one another, and they will send the traffic to the destination. This is our source, this is our destination. The routers in between know how to route traffic for different networks. Now, if we were, let me clear up a couple of things here. If we were on a real network, we would not be able to use these addresses on the internet, okay? Because these are private addresses here. 20.20.20.0 is a public address. So that address could be used. And that address is used between router 1 and router 2. So in essence, this router IP address could be routed over the internet. but the remaining ones wouldn't. So actually, if let's say Keisha was here, this router was in Brooklyn, New York, her IP address is 172.30.30.2. That address, when it goes out this interface, if this is to the public network, to the phone company, that IP address will be translated into something that is routable out to the internet. And there's a protocol just for that called network address translations, which will translate these private addresses to a public address so it can be sent across the internet, and the two devices can communicate. So even though private networks are allowed, they are not owned by anyone, and you're allowed to use them within your network, within your business network, you can use network address translation to route your local LAN traffic across the internet. So that's what we're simulating here when we go to Don's PC and we send a packet or a communication. Let's say this was an email that we sent to Keisha. It will go, the address will be translated and it will be delivered to her computer. So that's a simple, brief overview of how to set up a network. Now this is very simple. We didn't really go into any of the real details of the routing protocols, but those will come in following videos. I want to thank you for listening and have a nice day.